Hey everybody, this is Alex Merced and welcome to this video on data concepts. So basically the next several videos are going to be on different concepts to kind of lay out groundwork before we start getting back to being hands-on with things like Apache Spark and Dremio. So what I want to talk about today is what is a data frame, okay? And basically this has to do with just sort of how data is stored. So traditionally the way you would store data, okay, because most databases, we thought about things in a row-based way. So you would have rows of data. So in that case, the idea here, we're talking about data structures. Okay, regardless of what data structure I have, my data is the same. Name, let's say ID, name, age, 1, Alex 38. Okay, so that's like, let's say that's my data. Okay, and let's just add one more record. 1, Tony 35. Okay, so there's my data. So in a row-based world, what would happen is essentially you would have an array of rows. Okay, and essentially each row would kind of contain data. So it would be like ID, name, age. Okay, so the underlying data structure was essentially an array of rows, a collection of rows. So in this case, this would be 1, Alex 38. Okay. And there we go. Let's get the spacing right. Close enough. Okay. And then over here we would say like 2 Tony 35. Okay, and this is great when you're doing transactional work. So again, when I'm adding a row, deleting a row, it makes sense to have the data set up as rows. Okay, so this could be how you store it in a data file. Okay, so if you ever saw like a CSV file, okay, a CSV file would essentially store the data like this. You would just basically have each row be one line in the file separated by commas. And essentially the first row of data would be this. Okay, and this is all fine and good, but again, row-based. Now, if I'm doing analytics, the deal is, well, I might be doing something like getting the sum or average of ages. In this case, I don't need Alex and Tony's name. I don't need their IDs. I just need the data in the age column. But when you have a row-based structure, in order for me to do this sum, I'd have to load up both rows, which means all the information about the rows. And again, loading up more information means I'm using more memory, which can be an issue when you have very large amounts of data. But also, then once I actually load up this row, under the hood, I have to make my way from the beginning of this row to where that 838 is. So there is also some processing power in like traversing that row structure. Okay, so overall, it's going to take longer, use up more memory for doing that specific type of question. Like, hey, give me the average age, give me the total age, so forth. Okay, not necessarily adding and subtracting rows or updating a single row, which in this case, this is great. We want to do something different. So in this case, the approach would be to do it in a column-based structure, or columnar setup. Okay. So this would basically be the ID column, and we would have 1 and 2. Let's put that at the top. Okay. This would be the name, and this would be Alex and Tony. And then this would be the age. Age, which would be 38 and 35. Okay, so if we structure the data in a columnar format, this would be a lot better. So basically what would happen is I would just load up. So from basically when I'm reading the data, I would just grab the data from this column which means I don't have to load up the names of Alex and Tony. I don't have to load up the IDs. So I'm not reading that into memory, just the ages. And I can perform my mathematical operation. I'm not having to traverse data I don't need. I'm not having to load data I don't need, so I can process it faster and be able to do more work with larger data sets in memory. Okay, so that's so when we're doing analytical workloads, it makes a lot of sense to have your data structured in this format for your traditional sort of relational table-like data. Okay, so for your traditional sort of, again, table relational data sets, this makes a lot of sense. Okay, so the data structure, the name of this sort of structure is oftentimes referred to as a data frame. Okay, so and there's a lot of tools that allow you to work with data frames. So very popular are two libraries in Python called polars and pandas. Okay, these are libraries that allow you to load up data into a data frame. So you actually have a structure like this, and to be able to do sort of analytical operations. Say, hey, give me the average of this column. Okay, basically work with the data, but the underlying structure, like what it is that you have in memory, is structured this way. So to you, you're just working with your data. But again, what's happening under the hood is this. Okay, and that's the thing that to appreciate with data frames. Okay, data frames are a columnar structure. And the reason why we like the columnar structure is because of the type of questions we're asking. We're not saying update a single row. In that case, this is better. Okay, a traditional row-based table versus a columnar structure like this data frame here, which would be better for saying, hey, give me the average age. Okay, I just want the names of everybody. In that case, this is going to be better because I can only load up the columns that I need, do the operations on the data that I need, not on the data. I don't have to load up the data. I don't. Because you're oftentimes, again, doing analytical questions on not just a single row, but across multiple rows. So this just makes more sense. Yeah, so that's essentially what a data frame is. Okay, it's the structure, the way we structure the data as a construct that the computer has to work with. These are referred to as data structures. Again, depending on how the data is structured, will just depend on the amount of work the computer has to do certain things. And for analytical things, this tends to be a better structure. So now we can understand sort of like the nature of like row versus columnar and what is a data frame. Data frame libraries like polars and pandas just make it easy for us, particularly in this case in Python, to be able to load up data into a data frame and then work with it for analytical purposes. These aren't the only data frame libraries. There's data frame libraries in every programming language. When we get to Apache Spark has its own version of a data frame because it's doing distributed computing, which we'll talk about in a separate concepts video. But yeah, so that's the deal here. Okay, so we're talking about the structure of the data here. I'll see you in the next video.